Hey everyone, so I'm going to do the review sheet for your test. Okay, so question 1, it says the population P of Europe during the Black Plagues died off at a rate proportional to its decrease. When you see this, you should be thinking of y equals CE to the KT. After 14 years, it killed 1/3 of the population. Determine your value of K. So when I use this formula, what I need to do is fill in what I know. Well, I know that 14 years is my time, and after 14 years, 1/3 of the population had been killed. That means 2/3 of the population had been left over. So what I'm going to put here on the right is 2/3 of C. C represents the initial population. I don't know how many people I started with, but I do know that 2/3 is left over because 1/3 has died. So I'm going to put K, and then after 14 years this has happened. Alright, so I'm going to divide by C to solve for K. So we get 2/3 equals E to the K times 14. I'm going to use my properties of logs to bring down the K and the 14. So this cancels out to 1. This whole piece comes down. So I'm left with 14K equals ln of 2/3. I'm going to divide by 14. I'm going to get K as a value of negative 0.029. I'm around to 3 decimal places, and also this answer should make sense because it's decreasing and my rate is negative. Alright, the next question says the T virus infects people according to the equation dy dx equals ky. This is meaning sect. If you solve for it for y, you would end up getting this equation, where T is measured in days. If the virus infected 1/8 of the world's population in 5 days, how long will it take to infect half the world's population? This is a 2-step problem because they don't give you K, so there's no way you're going to be able to find out how long it takes to infect half the world's population. And you can see that when I set up this equation, because I'm going to have 1/2 C left over, and I'm looking for T, and I don't even know K, so I can't really move on. So what I'm going to do is I'm going to take the first piece of information they tell me, which 1/8 died in 5 days. This is going to help me find K. The reason why is because if 1/8 of the world's population had been infected, that means 7/8 were not infected. So 7/8 were left over. So what I have here is going to be able to let me find K. So I'm going to divide by C. 7/8 equals E to the 5 times K. I'm going to take the ln of both sides like I did in the last problem to get the 5K down, because this becomes 1. And then divide by 5. And then what I end up getting is a K value of negative 0.0267. I'm going to keep that decimal value, the long one, in my calculator, because what I'm going to do now is I'm going to put that same decimal value into the K value here. I'm going to solve just like I would normally solve. So I divide by C, 1/2 equals E to the negative 0.0267t. I'm going to take the ln of either side. That cancels to 1. So I have ln of 1/2 equals negative 0.0267t divided by negative 0.0267. And again, like I said before, if you kept this decimal in your calculator, you'd be able to do ln of 1/2, closing the parentheses, divide, bring down that negative value that you have from the first part of this problem, and you'll be able to get a T value of about 25.95 days. Next question says, given dy dx equals x squared y minus 1 cubed and f of 1 equals 0. The first question says sketch a slope field for the differential equation. So just take each point and plug it into the dy dx that's up at the top. The first value I plugged in was negative 2, negative 1. Negative 2, 0, I'm sorry. So I plugged in this point in first. So I put negative 2 in for my x and 0 in for my y. I end up getting a negative slope. And then I also got a negative slope here. I think this was negative 1. This one was also negative 1. I think this was negative 4, pretty sure. These all became 0. This is also 0. So again, I plugged all these points into my calculator. This was like 32, I think, that slope right there. It was really steep. I think that was 8. I think this one was 8 also. This one was probably 1. And this one was also 32. So this is pretty much my slope field that I ended up getting. It's pretty okay. I can kind of see the picture in it. Alright, so I did that first, and then it says find the equation of the tangent line at the given point. Well, this here is your slope. So all I have to do is plug in that point to get my slope. So I have, for part B, dy dx, which is going to give me my m, is going to be 1 squared, 0 minus 1 cubed. That gets me a slope of -1, and then when I plug it into y minus y1 equals m times x minus x1, I get y minus 0 because my y value is 0 equals -1 x minus 1, and then I end up just getting y equals -x plus 1. I don't need that 1 there either, so I'm just going to erase that. Okay, -x. Alright, so then the last part says find the particular solution to the with the given condition. So what I'm going to do is I'm going to solve for y using the given condition that was given to us. So the first thing I'm going to do is I'm going to cross multiply so that I can separate the variables on either side. So I put that over 1, cross multiply, so I have dy equals x squared y minus 1 all cubed dx. Now I want to bring over the y minus 1 cubed because it needs to go with the y on this side. This cancels. I end up getting x squared dx and then dy over y minus 1 all cubed. And now I'm going to take the integral. This side's easy. It's x cubed over 3 plus c. The next side's going to be kind of tricky for you guys. So it's really not that terrible. I see a y minus 1 on the inside of parentheses, and whenever I see something on the inside of parentheses, I try my best to use u substitution. So I'm going to let u equals y minus 1, and then I'm going to make du equal to 1 dy. Well, 1 dy is at the top, so really what I have here is I have the integral of du over u to the third. I replaced y minus 1 with u. And at this point, I could integrate. So what I'm going to do, I'm going to give myself some more room actually. So I'll bring that up over here. So I have integral of du over u to the third equals, this side's already integrated, x cubed over 3 plus c. And I'm going to bring this up to the top to make it u to the negative third so that I can integrate it. And remember, when you integrate, you add to the exponent, so this becomes u to the negative 2 divided by the exponent equals x to the third over 3 plus c. And I'm just going to rewrite this by plugging in the y again. So I have y minus 1 to the negative 2 over negative 2 equals x to the third over 3 plus c. And what I'm going to do now is I'm going to find c, because we want to find the actual solution. I'm going to find c by plugging in the point f of 1 equals 0. So 1 is x, so this becomes 1/3 plus c. And then this becomes 0 minus 1 to negative 2 over negative 2. So where am I right now? This whole side becomes negative 1/2, I believe. And you subtract 1/3. Those cancel. C equals, if I put a 3 here and a 3 here, 2 here and a 2 here, I get negative 5 over 6 as my C value. Yep, because that becomes negative 3 over 6, and this becomes negative 2 over 6. 3 and 5 make, well, 3 and 2 make 5. Alright, so I have my C value, and now what I'm going to do is I'm going to take that C value, I'm going to plug it into this step right here. So I have now y minus 1 to the negative 2 over negative 2 equals x to the third over 3 minus 5 over 6. And I'm just going to solve for y now. Okay, so first what I'm going to do is multiply by negative 2 on either side, just so I can get rid of it. And when I bring this in, I end up getting negative 2x to the third over 3 minus, well, positive actually because of negative and negative, be 10 over 6. Now this just becomes 5 over 3, which is kind of nice because now what I got going on is I have negative 2x to the third plus 5 over 3. Alright, because it's the same denominator. So now what I'm going to do is I'm going to make this 1 over y minus 1 squared because it's a negative exponent. And I'm going to use that 3/4 rule, which will allow me to bring my y minus 1 to the top. And if you remember, 3/4 rule just means that you're flipping the fractions on either side. I'm going to take the square root. I get y minus 1 equals the square root. And actually, there's two answers, plus or minus. And then I'm going to add 1 so that I can get my equation. Now the only issue here is that you have plus minus and only one of those answers could be true. So what you're going to do is you're going to plug in that point f of 1 equals 0 to see which one works, the positive or the negative radical. And the one that works is actually the negative radical. So this is my answer for part C. Next question says consider the differential equation dy dx equals 4x to the third over e to the 3y. Find a solution y equals f of x. That means I just want the solution that satisfies this point. And after finding that point, verify that that is the solution by using the point. So the first thing I'm going to do, like I did with the last problem, is cross multiply. So I get e to the 3y dy equals 4x to the third dx. Going to integrate. When you integrate e, you keep it. It's e to the ky over k, so it's e to the 3y over 3. And then 4x to the fourth over 4 plus c. Those go away. So now what I can do is I can plug in my point 2, 3 that they gave me. So it'll be e to the 3 times 3 over 3 equals 2 to the fourth plus c. That becomes e to the ninth over 3 equals 2 to the fourth is 16 plus c. Subtract 16. And this gets you your c value of c being e to the ninth over 3 minus 16. So what I'm going to do is I'm going to put that c value up here into this part right here. Alright, so this is going to become e to the 3y over 3 equals x to the fourth plus e to the ninth over 3 minus 16. I'm going to multiply by 3 on each piece here. So 3, those cancel, 3, 3, and 3. These actually cancel, so I get e to the 3y equals 3 to x to the fourth plus e to the ninth minus 3 times 16 is 48. And I'm going to take the ln of either side so that these cancel out and the 3y comes down. Ln of 3x to the fourth plus e to the ninth minus 48. My last step is to divide by 3. So y equals ln of 3x to the fourth plus e to the ninth minus 48 over 3. So that's my equation. The last part says to verify it with the point you're given. So f of 2 equals 3. I believe that's right. Yep. So what I'm going to do is I'm going to plug in the y for 3 and then the x over here. So 2 to the fourth plus e to the ninth minus 48 all over 3. And what I believe what happens here is this becomes, oops, so I get 3 equals ln 48 plus e to the ninth minus 48. These go away. And you end up with 3 equals ln of e to the ninth over 3. And ln and e become 1. So 3 equals 9 divided by 3. And there you go, 3 equals 3. So it works. The next question says, find the particular solution for dy dx cos of dy minus sine of 3x equals 0 if x equals pi when y equals 0. That's just a point pi comma 0. Alright, so what I'm going to do is get the dy dx kind of alone by separating. So I'm going to add that sine x to this side. sine 3x. Then I'm going to cross multiply, so I get cos 2y, and I'm going to put the dy second, and sine of 3x dx. I'm going to integrate. So the integral of cosine is sine 2y divided by 2, and the integral of sine is negative cos of 3x divided by 3. And remember, the plus c goes with the x. Now I'm going to find c by plugging in my y and my x coordinate. So I'm going to put in 0 for y. I'm going to put in pi for x. Okay. This becomes 0, and this becomes negative 1 times negative 1 plus c. So it's 0 equals 1/3 plus c. So if you subtract the 1/3, you get c equals negative 1/3. So I'm going to take that, put that into here. Alright, so I get sine of 2y over 2 equals negative cos of 3x over 3 minus 1/3. Alright, because that right side has the same denominator, I'm just going to make it easier on myself, and I'm going to put them over the same denominator. Minus 1 all over 3. And I'm going to multiply by 2 just to get the 2 away from this side. And I'm going to bring that in, so I get negative 2 cos 3x minus 2 all over 3. And to get rid of the sign on the left side, I'm going to take the inverse of it, so sine of negative 1. So these cancel, and I get 2y equals sine of negative 1 of negative 2 cos 3x minus 2 all over 3. And then I just have to divide by 2, and I think it was easier by multiplying by a half, just because you can just put the half on the outside of the sign, and you end up getting y equals 1/2 sine to the negative 1 of negative 2 cos 3x minus 2 all over 3. And there you go. Next question says, verify that the function y equals cx to the 6th when c is some constant to the differential equation. Now, I believe there's a typo here. This should not be over 6. It's just cx to the 6th. What I'm going to do is I'm going to take this 6y equals x minus x y prime. Y prime is the same thing as saying dy dx, so I'm just going to replace that. Then what I'm going to do is I'm going to add over the x dy dx just to make it positive. Then I'm going to cross multiply, so I get 6y dx equals x dy. Now the x's and y's are on the right side, so I'm going to bring this over here and this over here. So I get dx over x equals dy over 6y, and now I'm going to integrate because I separated them. This side is just ln of x because it's u prime over u. This side, what I'm going to do is I'm actually going to pull out the 1/6, if you don't see it, 1 over 6, and make it dy over y. So now you can see the u prime over u easily. Oh, and I also forgot the plus c here because I integrated x, so I should have put the plus c. Alright, 1/6 ln of y. Alright, so now all I got to do is solve for y. So what I'm going to do is I'm going to multiply by 6 on this side to get rid of this, and 6 on this side. So I get 6 ln of x, and I know that technically I'm multiplying the c by 6, but a constant times a number is still a constant, so I'm just going to leave it as c equals ln of y. And now what I'm going to do is I'm going to take the e of either side, so to cancel out the ln. And on this side, what I can do is I can separate this with multiplication because it's addition in the exponent, and maybe it'll make me reduce things. Now, this is kind of tricky because you probably haven't done this since Algebra 2. What you need to do here is bring the cowboy back on top of the horse, so bring this up there, because when you have a number in front of ln, you bring it on top of the variable that's in the inside to make it ln x to the 6th. That'll allow the ln to cancel out, bringing down the x to the 6th. This piece just becomes c because e to the c is just a constant, so there you go, it's verified. Next question says, if dy dx equals 4x cubed y, find the original equation that agrees with the initial condition f of 2 equals 4. So what I'm going to do first is I'm going to cross multiply by putting that over 1. So I get dy equals 4x to the third y dx. I'm going to bring the y over here because we want to bring the letters together. And now I'm going to integrate. So this left side is ln of y equals 4x to the fourth over 4 plus c. The 4's will cancel out. And now I'm going to solve for c by plugging in my point 2, 4. So I'm going to put a 4 in for the y and a 2 in for the x. So I get ln of 4, 2 to the fourth is 16. Subtract 16. So I have ln of 4, I don't need the absolute value bars anymore because it's positive, equals c. I'm going to take this thing and put it in up here. So I have ln of y equals x to the fourth plus ln of 4 minus 16. Take the e of either side. Y equals, I'm going to separate this with multiplication like I did the last problem, because I think it'll help me cancel out the ln with the that has the 4. This cancels. So now what I have is e equals 4, because the 4 comes down. E to the x to the fourth. Now, these two pieces here, they didn't reduce. So what I'm going to do is I'm going to bring them back together by doing x to the fourth minus 16. And there you go. I hope this video helped. Again, guys, remember, you can always check the particular solution by plugging in the initial condition they give you, the point, and if it works, then you have the right equation. If it doesn't work, you probably made a mistake. All right, I'll see you tomorrow. Have a good night.